Okay, friends, today we're going to go over 14.1. This is just over acids and bases, and most of this should be a review. So stick with me, and you need to do 14-1 homework, and I think it'll be fine if you do all of them, but double check the calendar to make sure that's what I put. Alright, first we're going to talk about acids. Acids are electrolytes, meaning that they dissolve in water, and you can run a current through them. Acids have a chemical formula that begins with hydrogen. We've already talked about this. And when they're put into water, like hydrochloric acid, they dissociate into the hydrogen and the chlorine. And the fact that these little chlorine ions are floating around, that's what allows electricity to travel through them. Because electricity is just a travel of electrons. Well, when you have negative ions, that's what it gives you. What you need to know is acids have a sour taste. Think about juices like orange juice has a little bit of a sour taste to it. Lots of other ones you really don't want to be tasting. Citric acid is pretty simple, and that's a lot like what's in your stomach. Also, acids change the color of acid-base indicators, and this will be on the EOC, I can guarantee. Litmus papers. If you look at this picture, for litmus, and you need to write this in your notes, and you need to memorize this, acids turn blue to red. Okay, the way I remember it, acids turn red. Well, if I spill an acid on my skin, it's likely to turn red. Okay, so acids turn blue litmus paper red. If you put acids in with the red litmus paper, it's not going to do anything because it won't be reacting and it's already red. The other one that you need to know is phenolphthalein. Phenolphthalein, and that comes up here in just a minute. I'm hopefully spelling it correctly. Phenolphthalein, it will be clear. It's a liquid, and when it's in the presence of an acid, it just stays clear. No color change whatsoever. So let's talk about naming acids. We've done this once before. Most of us have, at least. So when we name them, it's anything with a hydrogen, remember, a hydrogen and an ion attached to it. Binary acids have only two elements, hydrogen and that element. So here, if we're naming a binary acid, you start with hydro. Then you tell me the name of the anion. So up here at the top, the first one is hydrofluoric. The second one up there is hydrochloric. And the third one up there is hydrosulfuric. Has to have that hydro up front if it's just two things, okay? There's other ones. There's hydrobromic, hydroiodic. There's a bunch of them, and we've talked about them before. I'm going to show you the chart here in a second. Oh, well, here's every single one we just talked about. Hydrofluoric, hydrogen and fluorine. Hydrochloric is hydrogen and chlorine. Hydrobromic is hydrogen and bromine. Hydroiodic, hydrogen and iodine. And hydrosulfuric. Those are all of the big ones that you need to know. There are more to name. They're called oxyacids. Let's look at that in the next slide. When we name oxyacids, it always has hydrogen, because it's got to be an acid, has to have hydrogen, and an oxy acid always has oxygen. So let's look at these. The name of the oxyacid is based on the anion in there. So if you guys do remember this, we just change the name of whatever that anion is, and 8 prefixes change to X. I'll show you in a second. Ites change to us. You should probably write that down. Okay? So here, HNO3 is hydrogen and nitrate. So it's an 8, it's going to be going to ic. So we call it not nitrate acid, nitric acid. Now this one down here, this is acetate ion, and we call it, again has that ATE ending, acetic acid. This is basically vinegar. Now keep in mind it's not hydrogen nitric acid, it's just nitric acid. This is because it has an oxygen in there. This is something you need to memorize. Like I said before, if the suffix ends in "ite," you replace it with "us." So here, this is sulfite, SO3. So it goes from sulfite to sulfurous acid. Now, if it had been H2SO4, that would have been sulfate right there. That one is sulfuric acid. Okay, so keep in mind, ates go to ic acid and ites go to us acid. Here's what we need to know about bases. Bases are also electrolytes. When they always have that hydroxide ion with some cation attached, and when you put them in water, they dissociate like this. You get your cation all by itself, which here is sodium, and then you get OH, or hydroxide, floating around. Now, instead of being sour like acids, bases are bitter. Bases are very bitter in taste. Now, again, you don't want to be tasting them, but if you were to find some in your food or something like that, because they're very common, it would have a bitter taste. Now, when they're diluted, they feel slippery. This indicates that a lot of our soaps have bases in them. And bases are very good for cleaning, by the way. Here, for acid-base indicators, with litmus paper, you're going to use the red litmus paper, and it will change to blue. So you'll have to start with a piece of red litmus paper, and when you dip it into the base, it's going to turn blue. Now, how do you remember this? Well, base starts with a B, blue starts with a B. And then phenolphthalein, that clear liquid that we could drop into the substance to see if it's an acid or a base. Well, phenolphthalein turns bases blue or pink, turns them pink. So you got a little bit of pink, a little bit of blue. Just keep in mind the phenolphthalein turns pink. So again here, base starts with a B. Well, if I flip that over a line, I see a P. That's just a quick way I remember that. I'm going to show you guys this when I get back. We'll look at some acid bases and we'll test them out and see if you can figure out what is what. But for litmus paper, remember, bases turn blue. And if I use phenolphthalein, bases turn pink. So here's a couple of questions that I pulled off of EOC tests. Which of the following solutions will cause blue litmus paper to turn red? So you've got to figure out, is that an acid or a base? Well, if it turns red, it's an acid. So it has to have hydrogen as its cation. So it can't be A, can't be B. Now you're down to C or D. Well, which one would be an acid? Correct, C. D is water. Obviously, it's not acidic, not basic. Number 2, phenolphthalein is an indicator that turns pink when added to a basic solution. And which one would the phenolphthalein turn pink? Well, pink means it's a base. Had it said clear, you'd be looking for an acid. So if it turns pink, we're looking for the one that releases hydroxide in solution. Well, the only one with OH in it is A. Now, neutralization reactions are what happen when you react an acid with a base. Remember, these are double replacement reactions. So here, the hydrogen is going to replace the sodium, and the sodium is going to replace the hydrogen. When that happens, the hydrogen is with OH, which we could write water as HOH, and it would look the same. And then the sodium is now with chlorine. So remember, your products of a neutralization reaction are always some salt, so that's some cation plus anion, and water. Those are always your products. And salts are those electrolytes that dissociate into ions other than hydrogen and hydroxide. So if I put NaCl into water, it's going to dissociate or break down into sodium and chlorine. Okay. Alright, guys. So here's another reminder. In aqueous solutions, so in water solutions, neutralization is the reaction of hydrogen ions and hydroxide ions to form water. So here, look at the bottom down here. Do we have an acid? Do we have a base? We need to neutralize this and tell the salt that would be formed. So which one's the acid? Hopefully you know it's the one with hydrogen as its cation. And the base is the one with the hydroxide. So when I switch my partners here, barium's going to switch with hydrogen because they both have positive ions. I'm going to get H with OH, so it's going to be H2O. And who's barium with now? NO3, which hopefully you remember barium is a +2, so I've got to have 2 nitrates to balance. Then we have to go back and balance the actual equation. Well, I have 2 nitrates on the right, so I've got to have 2 on the left. And that gives me 2 hydrogens, 4 hydrogens total on the left, because I have 2 here and 2 here. So I've got to put a 2 there, and that balances my oxygen. So we're good with just those 2's. Now, just remember, you need to go over your notes, make sure you know which is an acid and which is a base. Always balance the reactions, and your homework is 14-1. Let's do all. Good luck.